Hello, everyone, and welcome to the OCX Webinar Week. My name is Irina, and I'm happy to have you all with us. This week, we are celebrating the lead up to OCX 26, our flagship event happening in Brussels in April 2026. It's the place where the open collaboration community meets to connect, learn, and exchange ideas. If you haven't registered yet, you can find the link in the chat. We'd love to see you there in person. Now, I'd like to give the floor to my colleague Perry, who will be briefly presenting sponsorship opportunities at OCX. Perry, you have the floor.
Everyone, and again, thank you for attending the webinar series. Anyways, I just wanted to reach out and let you all know that we do have some sponsorship opportunities for OCX 2026. These are, are a great opportunity for your organization to have visibility, both as an organization as well as your brand, by having, being up front, in front of over 600 attendees. So developers, professionals all across the industries. It gives you an opportunity to meet the developers, the decision makers, and ecosystem leaders through the 5 co-located events. We have automotive, AI, compliance, and research. There's some. It's a great opportunity to perhaps meet and develop some partnerships. Building relationships with other organizations within the open source community. We have 5 designated packages, and we also have the ability to customize packages based on your organization's needs and wants and their availability for the conference. We have some high-level sponsorships that will offer additional exposure by sponsoring a specific co-located event or 2, depending on the level of sponsorship. So if you're interested, please share this with your marketing team and have them reach out to sponsors@ocxconference.org, which I believe Irina will add to the email. I'd be happy to meet with your marketing team or yourself, and we can discuss some opportunities in more detail.
Thank you, Perry. Sorry for the small delay.
Oh, sorry, I thought my apologies. I didn't finish. I meant to say thank you for your time.
No worries at all. So thank you so much, Perry.
Okay, thank you.
Now we are going to the webinar. So today we are joined by Otavio. Let me bring you up the screen, Otavio. There you go. And unmute you, of course. Just 1 second.
Yeah.
Yes, so today we are joined by Otavio, who will be presenting today about From JDO to Jakarta Query, the evolution of persistence in enterprise Java. So if you have any questions throughout the presentation, please feel free to ask them in the chat or use Ask a Question tab. So we'll go through all your questions together at the end of the session. And make sure to stay until the very end, because we'll be running a Raffle Giveaway, where a few lucky attendees will win some prizes. All right, without any further delay, Otavio, over to you.
Okay, everyone. I'm super happy to be here. Thank you. So this week to celebrate the OCX webinar week. So today I will cover more about Java and history, naturally open source history as well. And I enjoy a lot the future. So let's also discuss a little bit more about the future. So today I will discuss more about the evolution of the persistence enterprise in Java, especially from JDO to Jakarta Query. Oh, hello, Dominica. So nice to see you here. So last week I was watching you, and right now you is out watching me. So that's nice. So I will discuss more about this integration of both the language layer and the database layer and how we can handle those together, right? So as I mentioned, let's discuss a little bit more about the history, especially because nothing that we are doing right now is kind of new, right? So for example, the persistence is something that we have been working a lot. So the persistence come from caves. And as you can see here, the main goal of the persistency is to guarantee a long term of knowledge, where we started with caves, and then we went to written records, and then libraries, the printing revolutions, to finally have what we live today with the digital storage and also the cloud distributed system. So when talk about database, the goal is not only to hold information, but to hold knowledge. So naturally, I put some data there, but together and aggregated, I can take decisions, I can take business decisions, I can move my application, move forward, and so on. And that's happened because a years time ago, someone decided to write something in the caves. And if something happened with the logic of programming, especially because if you think more about deep of what we're doing right now, we're discussing philosophy and logic shape in the programming. So naturally, when talk about programming, it's impossible to deny Aristotelian logic as Leibniz language, and then algebra logic. Finally, Ada Lovelace, Turing, and Church. And finally, we have what we have today with the modern language. So yes, we started with philosophy, we started with cave, and right now we have both. We have programming language and we have the persistence layer. But okay, Otavio, that is enough of philosophy, that is enough of history. I don't care about this kind of thing. Why do I care about database right now? What the challenge that we're facing? Naturally, when we talk about modern application, we need to answer that question, right? Why do we need database? I can summarize it on three. So the first one is it is where the state is. For example, right now we are discussing a lot microservice that is usually stateless. So where the state goes, mostly of the time goes to the database. It is where the opportunity is, and naturally is where the new opportunities are. So, for example, I'm running a new application, I got some ideas about my client, and based on those data, I can also evaluate a new product. So it's happened in my previous client that hold a black card, where we had a huge amount of clients, and then realized that those VIP cards, the clients enjoy a lot of wine. So based on that wine, based on that data, we created the winery, and based on that winery, it's become a huge in the country. So the current opportunity was the bank with finance, and the new opportunities come from the data and analyze the client behavior. And then we realize that people enjoys a lot of wine. So at least the people from these VIP cards. And naturally, when discuss database, it's not simple like discuss Java, especially because we do have a huge amount of flavors, types, structure, strategy of replication, and so on. So that's why, indeed, we have the approach or the concept of the polyglot persistence, because we are able to use the best database in the best scenario. So the analogy that I used to use when talk about the polyglot persistence is that it is pretty similar to the polyglot communication that we have in human language, right? So, for example, I'm Brazilian. When I go to Brazil, it makes more sense to speak Portuguese instead of speaking English. When I go to France, or Belgian, naturally, I will try to speak myself in French, or if I go to Italy, Italian, Spanish, Spain, or Latin America, Spanish as well. So with more lack of knowledge of language, I can adapt to the best case scenario as possible. So naturally, if I go to Spain or Latin America, I will find people who is able to speak English. But naturally, all the language, the native language is Spanish. If I go to with Spanish, I will communicate with more people and more easily inside Latin America, but not Brazil. So that's the whole point of the polyglot persistence. So we have several flavors. I can handle several ways to handle with my modern enterprise application. So the classic one that a lot of people have seen on the university, that is the relational database or SQL database, where we have a huge instance on this database. And then we have the chaotic world of NoSQL database that we don't have the standards. We have a huge amount of types. And naturally, when put those together, we are capable to define when, how, and why should I use one of those flavors. And actually, when talk about those flavors, they have one thing in common. That is the communication with my application layer, right? For example, right now I'm talking about Java, and I need to integrate that with my database. And both have different ways, different paradigms, different structure to hold my information. On this case here, I have my person, as you can see, that has a list of address, and then my address as empty. In this case, I have my pointer to define that this person has a list of address. But on my case here, when we talk about table and relation database, I have at least 2 tables or 3 tables to do this algebraic relationship. So I have a person address, and then my address. On this case, you can see that both have the same goal. However, the structure and how to those are storage are totally different. One goes to pointer, another one goes to table. And those difference goes beyond, especially because in application, we have inheritance, we have polymorphism, we have encapsulation, we have types. And on the other hand, in our database, if you are using SQL, you can go to normalization. If you are using a NoSQL database in general, you can go to denormalization. And when we talk about database, mostly all the time we are discussing structure, how to hold those information. And when you have the bridge to connect those, we face a huge problem that we call the mapping mismatch. Why? Because application has one structure, several behaviors in the paradigms, while the database, the structure, the paradigms, and so on. So in this case here, I'm only talking about NoSQL database. Those are my expertise, but as you can see, the same thing is totally applicable to relational database as well. So my database usually don't have inheritance, encapsulation types, and so on. So you can do the same thing about that on any kind of application. But with the time, we realize that both are amazing together, my application with my database. And then we start to do some attempts to see how we can connect both. Going to the history of the enterprise Java, the first step was JDBC. So it was the first bridge. Here you have the sample of the communication. As you can see, I opened the connection, then I created the prepare statement, and then I got my result set. So naturally, it was the first attempt, but as you can imagine, we included a huge amount of complexity, right? Because I need to do a mapper to my application to from my database, especially because, as I mentioned before, Java has several capabilities that the database don't. And the same thing happened with the database that contains some capabilities that Java don't. So on this case, I'm doing my super trivial query that I'm selecting users that are active, and I'm returning as ID, name, and mail, and then bring out of those information. Naturally, with the time, realize that okay, Otavio, it's a huge amount of entities. It's impossible to handle everything manually, to convert everything manually, and then that we could see the burning of frameworks. So the first one, so as I mentioned before, the code is to the same, but right now, instead of doing manually, we have the class, the user class, and then at that time we had a XML file. So this XML file handle the integration between both the class, the database. And here we have a couple of configurations. So I have my ID that is generated by identity, and then my properties like mail and so on. So to achieve on that time to have a mapper if without doing a lot of manual code, we need to go to XML file. How about that? And you complaining about annotation right now, right? So, and then we also had a migration because on that time, the whole enterprise was inside the JVM, and then it was born the Java EE or Java 2 EE, where the goal was to starting extracting those information and putting in the server. So it was born the empty beans with the query language and naturally some complexity. Here we have the case, so I need to have my interface, my user home, and then I need to do this kind of implementations and follow those ideas. And that was where it was born, the first query on Java. So as you can see, so we have the select u from user u where the name equals name. So that was the first attempt to have this kind of query inside Java. And meanwhile, naturally, when we talk about history, we could see a huge discussions outside the specification world as well. So at that time, Sun Microsystems run a couple of specifications. We could see some ideas and so on. And at that time, Gavin King created the Hibernate. And that moment was the community evolution. Near that time, we also have Rob Johnson discussing about Spring, about the book, and that book makes Spring that we have today. So we have a huge movement inside the community to discuss and contribute from the Java world since that time. In 2006, we have the birth of the JPA or Jakarta Persistence API. And the good news is we finally have annotations. And as you can see, we don't need the XML file anymore. So we have the entity to define the class is an entity, the table, and then those annotation that we are usually using. So we could see this huge impact interaction with JPA as well. So we are making our life simpler with this kind of code. We simplify it a lot with those using annotation instead of both XML and also the any configuration outside the code itself. Furthermore, I can see in the single file my relationship. So I can see what I have on my entity plus what I have on my relationship using those annotations. So we can say that that was one of the biggest revolutions inside Java and enterprise Java as well. The addition of annotation. And with JPA, it was born the JPQL, the Jakarta persistence, at the time, Java persistence query language, where the goal was to use SQL for objects. So as you can see, so we are doing the select U from user where uname equals name. So I'm setting parameter of Ada and then returning the users of this kind of query. Okay. And then with the time, we could see a huge impact in JPA. So they start using a lot of inspiration from Hibernate, for example, the huge impact on that. And based on that, we could see the increase of query and ecosystem around queries. So we could see the criteria builder from JPA 2.0. Remember, at that time, it was stand for Java Persistence API. So I could create my query and then find the select, where, or the by, and so on, and then the maximum of results on that kind of query. With the increasing of SQL and adoption, we also see the popularity of NoSQL database increasing. So especially between 2010 and 2015, we naturally could see that the majority is still relational database. However, we start to see more and more often NoSQL database, more flavors of SQL database. Is not only Oracle anymore. We have more flavors of open source database as well. So this report comes from Stack Overflow from 2 years ago. And right now we can see that it's not only about a single solution to talk about or discuss database. We have a huge amount of those. And move around, naturally, we'll start to see the migrations and the evolution of Java leaving Oracle at that time. So initially, it had a discussion to have microprofile at the time, especially there are a couple reasons. One of those was because people start to complain about the investment that Oracle did inside Java EE. So we created the Eclipse microprofile at the time, where the goal was to create a small piece of profile of Java EE, focus more in microservice. And then Oracle agreed to move a couple open source projects to the community. On this case, Apache received the Apache NetBeans, and then Java EE was received to Jakarta EE. So we could see a huge impact of those migrations. So it took 3-4 years to start to release new features, especially of this migration of IP. And meanwhile, with the popularity of SQL, we could see several solutions, including the Eclipse NoSQL itself. So The Eclipse NoSQL started by, at the time, in the JCP executive member. The initial idea was to move as a JSR, but with the migration, it was the first specification Jakarta EE ever in the process. So Jakarta NoSQL was the first one. And based on that, we created the Jakarta NoSQL specification. So it was based on the framework JNoSQL. And based on that, we have right now the Jakarta NoSQL. The idea is to have a pretty similar API design to don't increase the cognitive load for Java developers when they are working between SQL and NoSQL database. However, it contains a couple of unique capabilities. Okay, so this here is a simple case of NoSQL database using Jakarta NoSQL. I have my template. It is an interface that can have multiple specializations. When we talk about NoSQL, naturally we are discussing the capability of doing particular behaviors, and those particular behaviors matter a lot on NoSQL Word. So I'm checking the template. This one could be key value, document, graph, column, and so on. Then I have my car, that is a Ferrari. Then I'm searching this Ferrari, and finally find by ID and delete by ID. So, in that time, we start discussing more about, okay, let's have something pretty similar what Spring does. That was the repository, but with a huge amount of discussions, we agreed that, okay, Otavio, this idea does not belong only to NoSQL Word, but to SQL as well. So based on that, I created the Jakarta Data as, again, the second new specification on Jakarta EE Word. And the idea was naturally inspired by several Java frameworks, such as Spring Data, to have a repository definition inside the Jakarta EE platform. So on this case, as you can see, we have our repository, the interface, and we can do pretty similar job that Spring Data does. However, we have way more capabilities. For example, we are able to define operation by annotation. So if you want to go close to your ubiquitous language, go ahead. The annotation will handle anything else like that. For example, in this case, we have the garage as a code repository. But if you don't wish, what you can do is have a garage, and then a couple methods like car, parking, unparking, and using the save or delete annotation. You can have both your terminology inside the business and the operation as you wish. This sample that I mentioned before. So here we are defining the business terminology. So we have first the built-in repository that's pretty similar what Spring does, right? So I have my interface, I extend my cool repository, and then I have a couple of operations from the cool repository, and also I can create my own custom methods to do those kind of operations, and also I can customize my repository. As you can see here, the garage, the repository interface, and then I have my terminology with the annotation to do the action or the operation. In this case, I will insert when my car is parked in my garage. And naturally, when talk about Jakarta Data, it was the goal at the time to have a common layer. So it doesn't matter if you're going to use SQL or NoSQL. The idea is to centralize common behaviors of those specific layers in a single place. So in this case, I have my entity that is relational database. So I move to my Jakarta data provider, and this one goes to JPA, on this case, Jakarta Persistence API, and that I will convert those codes on tables and relationships. So my beer has an address and so on. And then something pretty similar will happen with NoSQL as well. So I have my entities, I have my annotations from NoSQL, then I have my provider, and naturally I have my NoSQL drivers that will convert that to the NoSQL structure. So this one here, it is a document database, so might be pretty similar to a JSON object, XML file, BSON, JSON, or any kind of structure pretty similar to that. So my Java has a couple notations, your own structure, and the repository will call the provider, and the provider will handle the whole operation to convert my Java objects to my database structure. Remember that we still need to face the mismatch paradigms, because we're handled with two different products, the language and the database. So on those ideas, so we got the Jakarta data, it was released last year, and then we'll start to realize and discuss, okay, why should we stop on that? Because Jakarta Persistent has a lot of things, a lot of ideas that we could use on another persistence specification as well. So, and based on that idea, it was born the Jakarta Query. The goal here is having a single language, a query language, a common query language to all those persistence layers. So the idea is from Jakarta EE 12, we have a Jakarta Query, the new specification that will centralize the query of objects to database, and all the persistence specifications go to need this specification. So Jakarta Persistence depends on Jakarta Query. Jakarta Data, the same thing. Jakarta NoSQL, exactly the same thing. So all of those specifications on the persistence layer will have in common one single specification. Considering that we have two database targets right now, the persistence and NoSQL, we have finally two specifications that are common among those specifications. So Jakarta Persistence will use Jakarta Data and Jakarta Query. Jakarta NoSQL will use Jakarta Query and Jakarta Data as well. To achieve that, it's important to notice that we are talking about different SQL database, SQL, NoSQL, or any database engine. To solve that, we have an idea of have at least two languages. The core, that is the minimum requirement to the language. So Jakarta NoSQL needs to support, and Jakarta Data needs to support one. And we have the name is still an issue. We are still discussing about the better name approach. So what I have in our GitHub repository right now is an extended language, but basically it is a language to relation database. So we have this one here, focus on relation database. And naturally the idea is to extend. So imagine, for example, we have a graph database and you want to create a new language based on the core language. So go ahead, you can use it. And with that point, we need to realize that when you look about the enterprise Java history, we can see that we were adapting based on community feedbacks, based on technology feedbacks, based on the economy disruptions, and so on. So in 1995, nobody were discussing about microservices, especially because the hardware was super expensive. So then we moved to Java 2 EE, where we finally start to break in modules, the two platforms. Spring made a huge impact in Java EE, especially Java EE6. So, and then we start to moving onto what we have right now on Jakarta EE11. So on those last 2 years here, we could see a lot of features, capabilities, including the persistence layers 1. So on Jakarta EE, we have our first specification that has the target to communicate with several database targets, SQL and NoSQL. So we got this one here. And on Jakarta EE12, I love to say that it's the data age of the specification, where we will have, hopefully, a polyglot persistency inside enterprise Java. So the goal is hopefully to include NoSQL 1.1 on Jakarta Data, on Jakarta EE platform. This way, we are capable to speak both SQL and NoSQL. Naturally, when talk about speaking, I'm discussing the language that is our Query 1.0. So those three here are strong candidates to Jakarta EE12. Hopefully, we can make it. And we talk about, okay, I discussed more about what happened in the past. Let's discuss a little bit what we can see in the future of the specification itself. For example, on Jakarta Data 1.1, we have more ways to simplify the communication integration. For example, on the previous version, we had the query where we can define by method or by query, but those are not capable to do dynamically. I mean, you can set the parameter. So if I do a select star from user where user is active or not, you are capable to define a parameter dynamically, but not the whole query itself. Right now, we can do it. So as you can see, we have the restriction as parameter inside my car that is returned as product. And then what I'm doing here is this kind of query. So I have my product find all, where I'm doing the product equal to physical price is greater than 10. And my name contains Jakarta. So on this case here, I'm running dynamically the query. So, and also exploring the meta model to generate some dynamic query. And as you can see, we have a huge capability and a huge power of doing query dynamically with Jakarta Data. We also have the capability of using the by that was usually by equals to have the condition. So on this case, I'm doing a find by person where the minimal year at least the first parameter and almost the max year, so the second parameter. So we can define those in my query. And actually, we have special parameters to handle this kind of thing. So on Jakarta Data, we can see more capabilities. So on this version, we can find that we are finally able to do dynamic queries on the specification itself, and naturally the integration with Jakarta Query as well. Then we have Jakarta NoSQL 1.1 that we finally can do this kind of dynamic query. Plus, we have new operations, so like contains, like count, and finally we can also delete using a Fluent API. So delete car where type contains SUV, or select cars where type contains SUV, order by name, ascending result, or the total, and so on. So on Jakarta NoSQL, we can see those specifications work super fine on this query, and also the integration of Jakarta Query as well. On Jakarta persistency, we have 4.0, we have two huge impact. The first one naturally is the knowledge transfer of JPQL, and also the support to new structures that comes from Java 21, such as the sequenced collection. And as I mentioned before, for me, it is the biggest impact inside Jakarta EE 12, finally a language to communicate using persistence layer. So we have the Jakarta Query that will keep the compatibility between persistence and Jakarta Data. But the goal is to deprecate those and move to a single place or a single specification. Here we have the sample using Jakarta Data. So we have our interface repository and then the query. And also we have a pretty similar approach on integration of Jakarta Query with NoSQL. So that is not totally different from what we have right now on Jakarta persistency. So I'm doing the firmware type equals, I will return the car type sports. And also I can have my projections using records. So I can do this kind of query using Jakarta Query integrated with NoSQL database. I guess it is not new for anybody here, but yes, you can use Jakarta Query with Jakarta persistence. So the goal is to don't break any compatibility between Jakarta persistency and Jakarta Query, at least in the version 1.0. That is what I'd like to show today. Naturally, we have a long way to move those specifications forward. It is an amazing opportunity to see key feedbacks and discuss those. My point here is more about how you can impact the whole humankind with software. So use and explore open source to achieve that. Open source can enhance your skills, to move your skill and move your career as well. So that's all for today. Naturally, pay attention on the list. We released the milestone 1 on Jakarta EE 12, so you can have the feeling of those impact. And naturally, it is a little bit about me. So if you wish, you can contact me. So my name is Otávio Santana, software engineer and architect. So Java champion, Oracle ACE director, executive member of Java, the ACP executive committee since Java 8. Apache Eclipse committer in Jakarta EE and microprofile as well. So I received a couple of awards such as Duke Choice Award, ACP Award, book. And when I have free time, I enjoy to write books and articles about Java and software engineering and so on. So thank you, everybody. It was good to you. And if you have any questions and doubts, please follow me on Twitter.
Thank you so much, Otavio, for this great presentation. We always appreciate having you with us. So let's see if we have any questions right now. I don't see anything in the chat yet, but let's give a couple of minutes to all the attendees because we can do the raffle at the same time.
Oh, nice. Let me close my presentation.
No worries. And let me just copy the list of all the live attendees into our raffle website. Just 1 second. And I will share my screen at the same time. Just 1 second, I'm doing this. There you go. So we have perfect. I think you should be able to see it now. So we will do it all together. So we will have 3 winners. The prizes are the following. We have the free OCX webinar ticket. Very exciting. And we have two 50 euros OCX workshop vouchers. So let's add them here. So we have our list of attendees below. There it is. So let's confirm, start, and now the countdown. So 3, 2,
1.
Nice. So Mohamed Peki Kanic, I hope I pronounced your name correctly. So you won a free OCX 2026 ticket. We will connect with you via email soon. And Anbu Sampat and Jose Diaz, you won a 50 euro OCX workshop voucher. Again, we will send you an email about that shortly. So congratulations.
Oh, congratulations, Jose. Super happy to you.
So let's see if, meanwhile, we got any more questions. So we just have really nice comments from Maximilian and from everyone else. Thank you so much. So last few seconds to ask a question. Maybe someone comes up with something.
Okay. Okay, Max did a comment. Yes, Jakarta Query is a URI first integration. So questions. So what is the newest specification that we are working right now on Jakarta EE 12?
Was that a question to the audience?
Yes, nobody asked me, so they might know everything.
All right.
So if there's nobody here with questions.
If there are no more questions, so thank you so much once again, Otavio. I'm really happy to have you with us every time. And thank you to everyone for attending this webinar. And I hope to see you at our next ones. I think we got an answer from Maximilian.
Yes, thank you, Max.
There you go. So thank you so much, Otavio. Thank you, everyone else. Have a great rest of the day. And congratulations to the winners. Bye-bye.
Bye-bye.